Hello student, I am Dr.A.K. Now I am continuing from the last class. Last class I have discussed work done under reversible condition, and we got the expression work done reversible, that is equal to minus 2.003 nRT log V final divided by V initial. Actually 2.303 came because we have converted ln, natural logarithm, into logarithm, okay, by multiplying by 2.303. Okay, now I am continuing that expression, free expansion. Then here free expansion means external pressure must be 0, P must be 0. Then in vacuum P will be, because no gas is there, nothing is there, that's why no pressure. Actually due to the molecules, gaseous molecules, pressure develops, but there in vacuum no molecules are there, no gas is there, that's why pressure is 0. Pressure is considered as 0. When pressure is 0, then no work will be done, because there will be no change in volume, because pressure is nothing. Then there will be no change in pressure, then no change in volume, hence volume change will be 0, and then work done is equal to pressure into change in volume, both are 0, hence no expansion. Okay, this is very, very important things I have told you. No work is done during free expansion of an ideal gas, whether the process is reversible or irreversible. One thing. Second thing, now we want to correlate this work done expression we have derived, that value we want to put or correlate to the first law of thermodynamics, that is the delta U is equal to Q plus W. Then here W value you have to put. Then we have derived W is equal to minus 2.303 nRT log V final divided by V initial. That value we can write there. Then here you can write, then what will happen, that delta U means change in internal energy, that is equal to Q in the place of plus W was there. Now you are writing expression for work, means in that first you write in the W, in the place of W, pressure into change in volume, that you can write. Then delta U is equal to, delta U will become Q minus P into delta V, because W is equal to minus P into delta V. That's why it will become Q minus P into delta V. And P into delta V is actually the work done. Then now for this, again work done expression you will write here, direct value of work done. Then now it will become work done is equal to Q minus 2.303 nRT log V final minus V initial. This is the relation between work done and volume, also change in volume. Okay, then this you have written, and also already you have written delta is equal to Q minus P into delta V. Only you have put the value of in indirect way, P into delta V is the work done, minus P into delta V is the work done. That value you have written here, no problem. Now, but this delta U is equal to Q minus P into delta V, commonly this is used. Now here what you have to do at this stage, with free expansion related to that, Q minus P into delta V you have written. Here that if pressure is carried, if the process, not pressure, process, if any process is carried out at constant volume means delta V is equal to 0, delta V is equal to 0. If a process is carried out at constant volume, that is a delta V is equal to 0, then what will be delta U? Then just see the relation I told you. So remember the relation, delta is equal to Q minus P into delta V, and delta V is equal to 0. Then P into delta V will come 0, hence only Q will remain. That's why delta is equal to QV. Q and down you write a small b means constant volume. Delta is equal to QV. Okay, both are equal. Because volume is 0. Okay, then from the above relation what I have discussed you, that delta is equal to Q minus P into delta V. Then delta V is equal to 0, hence P into delta V is equal to 0. Then delta is equal to Q reverse, QV. Q down you write a small b. Hence heat content and delta U both will be the same. Q is the heat content. Heat supplied, not content, heat supplied. Then heat supplied and internal energy both are same. If you can say delta V is equal to 0, means delta V is equal to 0 means delta U that is equal to QV. Okay, this is again second important relation I have told you. Okay, then if the subscript V in QV denote that heat is supplied at constant volume. Now next three relation I am going to tell you, that is again very very important for all your competitive examination, maybe medical, maybe IIT, maybe any other examination also. This is very very three relation I will tell. Then this is actually isothermal and free expansion of an ideal gas. Okay, what I discussed now, it is related to that only, isothermal and free expansion of an ideal gas. For isothermal means T must be constant. T is equal to constant. Okay, for isothermal expansion of an ideal gas into vacuum, when in vacuum means W is equal to 0. Why it is 0? Because P external is 0. That's why W is equal to 0. This you keep in mind. And also Joule determined experimentally that Q is equal to 0. Q is equal to 0. Then now just you remember the formula, delta U means internal, change in internal is equal to Q plus W. First law of thermodynamics. Then here W is also 0. W is 0 and Q is also 0. Hence delta U is equal to 0. Okay. Delta U is equal to Q plus W. But here in free expansion, W is equal to 0 and Joule also experimentally determined Q is equal to 0 in this case. Then here Q is also 0 and W is equal to also 0. Hence first important relation, that delta U is equal to 0 in case of isothermal and free expansion of an ideal gas. Okay, wherever free expansion will come, then you think for the vacuum, and in vacuum pressure is 0, then no work done, volume is also 0, all things are 0. Okay, then here in this case delta U will be also 0. Delta U is equal to 0. Keep in mind. Now again you can see that delta U is equal to Q plus W. Then Q is equal to what? Q minus W. Okay, delta U is equal to Q plus W. Okay, then for an isothermal irreversible, not reversible, irreversible and reversible change, for both I will tell you, then delta U is equal to Q plus W can be expressed for isothermal irreversible and reversible change. For both I am telling now. First, for isothermal irreversible change, irreversible, not reversible, irreversible change. For that, because for the free expansion, delta U is equal to 0. Delta U is equal to 0. Then in the first law of thermodynamics, delta U is equal to Q plus W. If you apply here, then delta is equal to 0. Then Q will be minus W. Q is equal to minus W because delta is equal to 0. Then Q will be delta is equal to 0 means 0 is equal to Q plus W. Then Q is equal to minus W. And minus W means P into change in volume. That is the V final minus V initial. Okay. Hence Q is equal to minus W, and minus W means P into change in volume, and change in volume means V final minus V initial. Okay. This is the one relation. Second relation, for isothermal reversible. For reversible I am talking about. Then here isothermal means T is constant. For isothermal reversible change, Q is equal to minus W, and minus W is equal to what we have written upside, same things. For in case of free expansion, both equations are same. Means Q is equal to minus W, and minus W is equal to nRT ln V final divided by V initial. What we have derived work, expression for work, same things. Means in both cases, in case of irreversible or in case of reversible, Q is equal to same value. Okay, that is a Q is equal to nRT ln V final divided by V initial. This expression also always you keep in mind. Okay. Then here in case of free expansion, Q is equal to minus W in both cases, in case of irreversible and reversible. And minus W, you are knowing that minus W is equal to nRT ln V final divided by V initial. That also ln you can convert in log, then it will become 2.303 nRT log V final divided by V initial. If you are talking about the expansion, in expansion work is done, that is the minus. Keep in mind, expansion in the case of reversible only I am talking about. In case of reversible work you are doing, that is the by the system, it means minus. Hence that minus, and in expression minus is there, then minus become plus. Minus it will become plus. Then in case of expansion, here for isothermal reversible change, okay, here Q is equal Q is equal to minus W is there, then now W value in case of expansion, because work is done by the system, it will be minus. Then 2 minus became, already one minus was there, minus W. Now again due to the expansion one minus, then minus minus plus. That's why it will become Q is equal to 2.303 nRT log V final divided by V initial. This is the second relation. Now actually in second relation, once you told in the term of ln, other you told in the term of log, same things. Okay, and only here important thing was there, that it was minus W, now it became plus. Okay, work done became plus due to the expansion, isothermal reversible change. That's why it became plus. Okay, now third relation for adiabatic change. For adiabatic change, then no heat will be supplied, no it will be entered, and Q is equal to 0. Then there in delta is equal to Q plus W. Delta U is equal to Q plus W. Then now Q is equal to 0. Then in this case, in case of adiabatic, W is equal to delta U. Change in internal is equal to work done reversible. Work done, not adiabatic, you can write adiabatic. Delta U is equal to work done AD. A small AD you write, just work W, there near that AD. Then in case of adiabatic change, delta U is equal to that is equal to WAD, because Q is equal to 0. Adiabatic condition you have to apply. Then in delta U is equal to Q plus W. Delta U is equal to Q plus W. Then in adiabatic case, Q is equal to 0. Then work done and internal energy both will be the same. Hence delta U is equal to WAD. And here one more thing I want to tell you, that internal energy, its symbol is U. Already I told you. Sometimes and in some books they will write E also. E means energy. Okay, hence don't confuse. Sometimes in the place of delta U they will write delta E also. Both have same meaning. Okay, don't confuse. Now I am giving just some 2 numericals, 2-3 numericals, easy numericals. Just I will discuss here, and you can judge whether you have understood or not. You will apply only this formula, what I have discussed. Okay, by problem solving, you will know whether you have understood or not. Okay, now just I am reading a question, but question you read very these things seriously. Okay, and try to understand. See, first question. 2 liter of an ideal gas, 2 liter volume they have given. 2 liter of an ideal gas at a pressure of 10 atmospheric pressure they have given. This 2 liter of an ideal gas at a pressure of 10 atmospheric expands isothermally into a vacuum until the initial volume is 10 liter. How much heat is absorbed and how much work is done in the expansion? Okay, this is the question. Again I am reading one more time. 2 liter of an ideal gas at a pressure of 10 atmospheric pressure atm 10 atm expands isothermally into a vacuum until its volume is 10 liter. How much heat is absorbed and how much work is done in the expansion? Then here, how will you solve? Think. 2 liter gas expanded. Okay. When atmospheric pressure was 10 atmospheric pressure, that time it expanded. Okay. And it became 10 liter. From the 2 liter, it became 10 liter. Means the initial volume 2 liter, final volume 10 liter. Okay. And pressure was how much? 10 atmospheric pressure. Then see here, expansion is going on. Expansion is going on. Okay. Then pressure was 10 atmospheric pressure. Then how much work has been done? Then relation you are knowing. Q is equal to minus W. Q is equal to minus W. This is the actually distance formula. Here you will apply Q is equal to minus W, because you have to calculate work done. How much work is done, and also you have to calculate how much heat is absorbed, because work has been done, then heat has absorbed only then. Then relation is there in both Q and W. Q is equal to minus W, and minus W means you will write P into change in volume. P into delta V means change in volume. Then final volume minus initial volume. Then here final volume is 10, initial volume is 2. Then and pressure is 10. Okay, pressure is how much they have given? Gas at a pressure of 10 atmospheric expands isothermally into a vacuum. Vacuum means pressure will be 0. Initially pressure was 10, but it wanted to expand in vacuum. Then in vacuum, what will happen? That pressure will be 0. Then here pressure is equal to 0. Then 0 into 8. 0 into 10 minus 2. 0 into 10 minus 2 means 8 minus 8. 10 minus 2, 8 into 0. That is the 0. Hence, no work is done. Vacuum means no work is done automatically. Without solving numericals also you can tell. No work is done. No heat is absorbed. Okay. This is the, I told you, this answer of the first question. Second question, now you can see. Same question, condition is changing. Question number 2, consider the same expansion, what I told you, means question 1. But this time against a constant external pressure of 1 atmospheric pressure. Now, that time was in vacuum, now it is not vacuum. Pressure is, means expansion took place against a constant external pressure of 1 atmospheric pressure. This is another, it is not vacuum. Pressure is from the 10 atmospheric pressure, it expanded to 1 atmospheric pressure. Okay. Now pressure is given 1 atmospheric pressure. Then what will be, you can say work done and Q. The same formula you can apply. Q is equal to minus W, and minus W is equal to, now because expansion is going on. Okay. Then real expansion is going on. Then this time work will be done. That's why minus W. then minus and minus plus. Always keep in mind, because expansion is going on. The expansion is going on, then work will be done, then it will be minus W. Then in formula already one minus is there. Again one minus, then minus minus plus. And W is equal to P into delta V. Then pressure is equal to 1. And V2 minus V1 means V final minus V initial. That is equal to 8. Then 8 into 1, that is the 8 liter atmospheric pressure. ATM, 8 liter ATM. Then Q and W both are equal. Both are equal. Heat absorbed is 8 liter atmospheric pressure, ATM. And work Q and W both are 8 liter ATM. Okay. Now question number third. Again same condition according to question number 1, what I told you, same things are there, only condition is changing. Consider the same expansion to a final volume of 10 liter. Okay, 2 liter was there, now just expanded to 10 liter. Okay, consider the same expansion to a final volume of 10 liter. 2 liter became 10 liter. Okay, conducted you can say reversibly. Now condition they applied that this expansion took place reversibly. Whenever question of reversible will come, then you apply the formula what I have derived for expansion, expression for work done. That formula you have to apply, means minus 2.303 nRT log V final minus V initial, because 2 initial volume they have given, and it is done reversibly. But in other 2 questions they have not told any things about the reversibility. If they will not tell anything about processes reversible or irreversible, then simple formula you can apply. Work done is equal to minus P into delta V. If reversible term is coming in question, then you apply this formula, work reversible formula, WREV. That's why it written WREV. Even work done for, if question is coming for work done in reversible case, then this formula WREV you can apply. Then in this question, volume of final and volume of initial is required. Okay, then only this log 10 divided by 2, final divided by initial. Then in the formula Q is equal to minus W, and here you will write minus W. There already this expression was in term of minus, then minus become plus because expansion is going on. Then 2.303 into 10 log, okay, 10 log, and here 10 divided by 2, 2.303 nRT is there, nRT. Then here after putting all value you will get actually means n value, r value and t value. Okay, nRT. Then here they have in question they have given 2 liter of an ideal gas at a pressure of 10 atmospheric pressure, expands isothermally into a vacuum until the total volume becomes 10 liter. Okay, then it is a 10 liter. Then here nRT, mole mole they have not given clearly. R value, T value, in that situation you consider 1 mole only. 1 mole only. You all things you take in a normal way. Then nRT, then 8.30, 8.314, and this T value and R, if you will take all, then it will come 10. It will come around 10. Then now, after solving all the things, then you will get value 16.1 liter ATM. You will get, after putting all value, 10 nRT. You required nRT, but N they have not given, R they have not given, T they have not given. If they have not given, then you can consider normal. Okay, universal gas constant you can consider normal way, temperature, normal temperature, and number of moles 1 mole. Then you will get value after keeping all the things. Final initial volume already they given. Then you will get final, you can say 16.1 liter ATM you will get. It means work done and Q. Both are actually heat only. Heat energy. Work is also heat. Heat is energy. Then both are here. Same value will get 16.1 liter ATM. Okay, because you have applied Q is equal to minus W. As whatever value is getting, both are same because both are heat only. Then now I am stopping only here, and next class again we will meet. Thank you.